Scientists have observed that the universe is expanding. This means that the space between galaxies and galaxy clusters is continuously stretching out, causing them to move away from each other over time. Imagine the universe as an inflating balloon. As the balloon expands, the distance between any 2 points on its surface increases, even though the material of the balloon remains the same. Similarly, the fabric of space itself is stretching, causing galaxies to move apart from each other. The observable universe refers to the portion of the universe that we can see or detect. Because the universe has a finite ago, light from extremely distant objects has not had enough time to reach us yet. As a result, there is a limit to how far we can observe in space. To illustrate this, let's use an analogy. Imagine you are standing in the center of a dark room with a flashlight. The light from your flashlight illuminates a certain radius around you. However, there are parts of the room beyond that radius that are still in darkness because the light has not reached there yet. The size of the illuminated area represents the observable universe, and the dark area beyond is the unobservable or unreachable parts of the universe. To clarify, the universe is finite in size. The observable universe, a term referring to the part we can see, is 93 billion light years across. That means that the stuff that was 15 billion light years away, about 13.7 billion years ago, is still potentially visible, and stuff that was further away than that back then is no longer potentially visible. For example, approximately 20,000 stars per day disappear from view. So basically what we see right now is the light that left things when they were 13.8 light years from where we are now. Add to that the stuff in the universe is on a multi-galactic scale, getting further apart as the density of space-time drops. The rate of this is about 70 km per second per megaparsecond. A megaparsecond is about 3.3 billion light years. So this is a line of sight issue, and it's the part of the universe we can still see the light from. So if we look at things that are 13.8 or so billion years away when the light left them, all we see in directions is a hot dense state. Now that 13.8 billion years ago, everywhere there was a hot dense state when space-time was very dense. If you imagine Earth at the center of its own spherical field of view, and as far as we can see in any direction from there as the radius of a large sphere, the first ring of that sphere that represents the hot dense state and light leaving it 13.8 billion years ago. So a radius of 13.8 billion light years. If the radius is 13.8 billion light years, that makes the diameter double that, or 27.6 billion light years. When you do the math for the distances growing due to the aforementioned density of space-time dropping, it means the total diameter of what we can observe is about 93 billion light years across. And due to the continuing space-time density drop, things are becoming further away than that and disappearing from our view as we speak.